Hello everyone, today we're going to be going over the 2026 FE Goes MA exam, problem 12. Now first I want to start with the physics joke of the video. It is, what did Donald Duck say to the physicist? Cork, cork. Okay, so let's start by reading the problem. A wake surfer of total mass m, surfer plus board, is being towed at a constant horizontal velocity v across a flat lake. The wakeboard has a specific geometry such that at this speed, it is partially submerged, and it provides a static buoyant force, Fb, where Fb is less than mg. To support the remainder of the weight, the board moves with an angle of attack theta relative to the horizontal water surface. Assume that the water exerts... Okay, sorry, I'm going to underline this. Okay, assume that the water exerts a reaction force strictly normal to the bottom surface of the board. Which of the following expressions represents the horizontal tension T in the rope and the tow rope required to maintain this constant velocity? Okay, so let's start by drawing a free body diagram. Now, basically what a wake surfer is, if there's so this is being towed, right? Let's say it's being towed by a boat. And there's this guy. He's standing on a surfboard and it's pointing this way, right? Because the water is... So if this is the water surface, right? Okay. So he's being towed like this. So this is the angle theta. Now, if I zoom in on this, okay, so he's being towed, right? And, it says that, so there's the total mass m, right? So if this is the center of mass, there's going to be a force mg pointing downwards. Now to support that, it says that it provides a static buoyant force Fb, okay? And we know that the buoyant force always points, like in this case, it points upwards, right? So it's Fb pointing upwards. And the reason it's pointing upwards is because, like, it's just, it's submerged in water, right? So it wants to go to a lower density. Yeah, so to support the remainder of the weight, the board moves. Okay, so we have this tension over here, right? And there's also, look, there's a reaction force, right? I'm going to call the reaction force Fr, okay? Strictly normal to the bottom surface. So it's kind of like a normal force, right? If I draw this Fr, right? But remember, it says over here that it's a constant horizontal velocity. Wait, it says over here that it is moving at a constant horizontal velocity v. So that means that this tension force and the horizontal component of Fr have to cancel out. So we can make an equation, right? T equals Fr. Now here, if this is theta, then this is going to be theta, right? And then the horizontal component of this is going to be sine theta, right? Fr sine theta. But we need an equation for Fr, right? So we can take into account Fb and mg, and that the forces are balanced in the y direction. So Fb plus Fr. Now, in the y direction, it's going to be cosine, right? So Fr cosine theta equals mg. In solving this, we get that Fr is going to be equal to mg minus Fb over cosine theta. And now, if we plug this back in to the top equation, we know that T equals this thing times sine theta, and since sine theta times cosine theta is sine theta divided by cosine theta is tangent theta. T is going to be equal to mg minus fb tangent theta. And that corresponds to answer choice B. So that's our answer. Okay. Thank you for watching this video. If you have any questions or comments, you can leave it in the comment section. And thank you for watching. Yeah, please like and subscribe.